Today we're going to talk about properties of logs. And they're related really closely to the properties of exponentials, or properties of exponents. So when at the top you see you have the same bases, a to the power of n times a to the power of m. And do you remember what you do with the exponents? Add them. So it's a to the power of m plus n. Okay, when you divide the same bases to different powers, what do you do with the powers? Yep, so it's m minus n. And when you raise a power to the power, what do you do with the exponents? Good, m times n. And this one is supposed, okay, so when you have a raised to the power of a rational exponent, where does the n go? On the outside, and the m goes up here. And then anything to the power of 0 is 1. Okay, so we're going to use those same types of properties because remember that these functions are related to each other when you see something like this. Now this is called the product rule. When you see the log base b of two things multiplied together, in this case u and v are multiplied together, I can resume recording even though I lost connection. Okay, so when you have a product rule, when you multiply two things together, it's called a product. And when you multiply u and v together, we're going to undo that. We're going to go kind of like backwards. And so you're going to have the log base b. You're going to have log base b of u plus the log base b of v. So with the exponents, when you multiply them together, you added the exponents. Now when you're multiplying, you're adding the logs. And with a natural log, it's the same exact rule. U plus natural log of v. Okay. So the quotient rule says log base b, u over v. What do you think we do with the logs now when we break them up? Subtract, right. So you'd have log base b of u minus log base b of v. And then the natural log, it would be the same rule, same process, but just with a natural log. Okay? And then there's this thing called the power rule, where you have log base b of u to the power of n. So what happens to that power of n is we just bring it right out front. So we have n times log base b of u. And the natural log, it works the same way, n natural log of u. Okay, so those are the three rules that we're going to use to do some of the problems below. When it says expand, that just means we're going to take something that's like on the left, and this would be expanded. When you condense, you start here and go this way. Okay, good so far? Mm-hmm. All right. So down below, they want us to expand each logarithm. So now I have the log, and it's log base 10 of 5 times x. So this would be, what would we do with the 5 and the x? We'd split them up, and you'd have log base log of 5 plus log of x. Okay. Number 2, we would use rule number 3, which is the power rule, and you were going to bring the 7 out front, and you'd have 7 log base 3 of x. Okay, so those are the simple ones. Then they get a little bit more complicated, where you're going to combine rules. So the first thing we're going to do is we're going to take, you have the natural log of 4 times x squared times y cubed. So we're going to use the product rule first, and we're going to break it up. We're going to say natural log of 4 plus natural log of x squared plus natural log of y cubed. So that's step 1. Step 2 is we're going to use the power rule on these two terms. So this 2 would come down in front, and this 3 would come down in front. And you'd have the natural log of 4 plus 2 times the natural log of x plus 3 times the natural log of y. And you're done. There's not much else. There's nothing else you can do. Okay?
Do we need to memorize all the properties?
Yeah. Yep, I would memorize them. Once you do these problems enough, you'll have them memorized anyway. Okay, the next one, number 4. When the quotient rule is when you divide. So what are we going to do with these two logs when we break it up? We're going to add or subtract. Subtract. So log base 4 of 10 minus log base 4 of 3. Okay. This number 5, we're going to use the quotient rule first. So you'd have log, or natural log of 6x cubed minus the natural log of y to the 4th. Okay, there's one step. And then we're going to break up. Now we have, in the first expression, this is multiplication, so we're going to break that one up some more. And so we're going to have the natural log of 6 plus the natural log of x cubed minus natural log of y to the 4th. And the last thing you're going to do is use the power rule and bring the 3 out front and bring the 4 out front. So you'd have natural log of 6 plus 3 natural log of x minus 4 natural log of y. So right now, I know this seems kind of boring, but right now we're just doing the mechanics because you're going to be solving problems that involve different numbers that aren't so easy. And so these are the properties that we're going to apply to solve real world problems later on in the unit. Okay, and number 6. What's a different way? I have the square root of 9x. How else can I write the square root of 9 times x? How can I write that with a rational exponent? What would it be? 9 to the power of what? 9x to the power of what? 1/2. Good. So we're going to rewrite this as log base 3 of 9x to the power of 1/2. And then what do you do with that 1/2?
You move it to the front.
Bring it to the front. So I have 1/2. And then I'm going to write this one as I'll do it step by step. I was going to skip a step, but I'll do it. Log base 3 of 9 times x. So now what happens to the 9 and the x? I break it apart, and do I add or subtract? Add. So this is 1/2, and it's times the whole thing. So we're going to put a parentheses here and put log base 3 of 9. Log base 3 of 9 plus log base 3 of x. And there we go. That's your answer. Okay, so that's what's called expanding. So we're taking those properties and we're using it to expand. The next section takes the properties and uses it to condense. Okay, you guys good to go? Right. So this right here, condense each expression to a single logarithm. So you have to look and see, we're adding right here, but there's a 6 and a 4 out front. See the 6 and the 4 out front. So when there's 6 and a 4 out front, where were they before? They were exponents before. So now we have ln of 2 to the power of 6 plus ln y to the power of 4. So that's the step one. And now we're adding, what was it before? We multiplied 2 to the power of 6 times y to the power of 4. And what is 2 to the power of 6? You guys see all have calculators. What is it?
$64.
64. So we're going to write 64 in here instead. And that would be your answer. Okay? The next one, we're going to move these back up here. We're going to move the exponents back up. So we have log x to the 5th minus log y to the 4th. And then we're subtracting, so when we subtract it, if we're going backwards, what does that come from? Dividing or multiplying? Dividing. So log x to the 5th over y to the 4th. And we're done. Okay, number 9. We're adding, but we're going to move this 1/3 up to the front. And we're adding, so what were we doing before? Multiplying or dividing? The expanded form is adding, so when we go backwards in the rules, where were we? Multiplying. So we're going to say log base 5 of 4 times x to the power of 1/3. There you go. Okay, 11 and 12, they want you to evaluate a logarithm, and they're giving you some values. So let's take a look at what they're doing. It says, use log base b x equals 4, log base b y equals 3, and log base b of z equals 2 to evaluate the logarithms. So the first thing we're going to do is expand this. So if we're dividing, here's a quotient. So when you're dividing, are we going to add and subtract the two separate logs? That would be the first one. Do I add or subtract here? Subtract, okay, log base b of z. Okay, and then I have these, this is multiplication, so I'm going to break it up even more using the product rule. So this is log base b of x plus log base b of y minus log base b of z. Now I'm going to make a substitution. It tells me that log base b of x is 4. So instead of this, I'm going to write 4. And it tells me log base b of y is 3. So I'm going to write 3 instead. And then I'm going to substitute 2 for log base b of z. So 7 minus 2 is 5. So the answer is 5. So that's all they wanted you to do there. Okay, last one. this one, I have a product, so I'm going to break that up first. So log base b of x plus log base b of z squared. And then I'm going to use the power rule and bring that 2 out front. So this is log base b of x plus 2 log base b of z. And then I'm going to take what they give me and I'm going to make a substitution. So log base b of x is 4 plus 2 times 2, which is 8. And that's it.
Wait, how did
Wait,
you,
4 plus 2 times 2?
Yeah.
Oh, okay.
how did you get from all of that to 4 plus
Because what
2?
what they get, see up here where I'm circling? They gave you the values of those. So log base b of x is 4. They just gave them to me.